back to Forward CloudSec. Reminder again, I'm going to say this every time, please fill out your surveys. Those help us in know what we need to do better next year and get your feedback. We truly appreciate it. Those are on the Cloud Security Forum Slack. If you look at the hashtag or channel for Forward CloudSec, there's a link there to those surveys. This talk is Unlocking Cloud Build Security with OIDC by Zach Steindler over here. Before we start, I'd like to thank our sponsors, especially our bronze level sponsor, OpenRaven. OpenRaven is the leader in cloud native data classification for security. The OpenRaven data security platform helps organizations pinpoint data security and compliance risk, apply data guardrails, prevent incidents, and streamline response. For everyone in the room, please make sure to silence your cell phones. We will use the mic for questions. For remote attendees, we'll be looking for questions on Slack and Twitter. Please welcome Zach.
Hello. I'm going to try to do this talk with a mask on. Hopefully it works out all right with the audio. Is anyone building software at least partially in the cloud today? Yes. So usually what happens is that your access keys get spread everywhere. Recently, though, there's been some developments in cloud CI/CD systems that make it so that you don't have to do that anymore. And so this talk is going to walk through what that looks like, how to apply it, and then some really wacky things that enables at the end of the talk. So almost everyone raised their hand. I probably don't need to convince you it's a good idea to build things in the cloud. Most of the time we have this tension where when developers are getting started, they want to build things on their laptop. It enables quick iteration, but also they can go through a SSO flow to contact internal tools. They can be on a VPN to contact internal tools. It makes it very easy for them to construct a build process. On the flip side, of course, we want to have an ephemeral build environment with as much audit and logging as possible, which makes us want to build things in the cloud. But of course, then how do we integrate with all of those systems that we want to connect to? When I first made this slide, I was going to say that humans and robots obviously aren't the same thing. Now I'm not so sure. There's more parallels than I thought. So just like the most frequent way for humans to log into a system is a password, the most common way for robots to access another system is via an API key. Essentially, though, these are the same thing, right? It's a shared secret between two parties to establish some sort of authentication. There's different things that work better for humans than a robot. It's very hard to convince a robot to tap a YubiKey. However, we can look at this concept of single sign-on for humans, and we can figure out a way to apply that as well to our automated systems. So even if we're not asking our automated systems to literally go through a web flow, we can use the same idea of federated identity. This is a bit of a refresher. It feels a little silly explaining to everyone what single sign-on is when we literally do it 12 times a day. But I wanted to introduce some terminology that then we're going to use again in the second use case. So there's a service provider. That's the website you're trying to access. In this case, Talk to Graham for dogs. But they're a busy startup. They're busy worrying about downturns, down rounds, being thought leaders. They don't want to implement their own authentication system. So they choose instead to say, megacorp, they've existed for a long time. Everyone already has an account. They support WebAuthn, which we don't want to implement ourselves. They have account recovery flows. We're just going to outsource all of our authentication to Megacorp instead. They're our identity provider. This looks quite complicated, but again, this is something we do dozens of times per day. Instead of going through the whole flow, I wanted to call out a few specific parts. So you start by contacting the service provider. That's number 2, or number 1, I guess, that redirects you to the identity provider. And then after you've done the authentication, step 3, you get assigned JWT, a JSON Web Token. And so this is what contains your identity information in it. You bring it back to the service provider, and then they directly validate that with the identity provider. And that's how identity federation works in the case of humans. Okay, so now, again, with robots, it's the same but different. Here, we're starting our flow with the identity provider instead of the service provider. And you could always construct different scenarios where each person is a different party. But in this case, the reason why the CI/CD system is our identity provider is because they're the ones that know about the workload. They know, who initiated it, if it was manually started, what repository it's coming from, that sort of thing. And then our service provider is our cloud infrastructure. So if we're doing a deploy, we want to take our resulting build and make sure it's actually running on our infrastructure. Maybe you want to contact a secret store as part of your build. So there's a lot of different options here. For the CI/CD provider today, there's a couple of them that support OIDC. So GitHub Actions, Google Cloud Run, or you could run your own Tekton chains deployment yourself. There's a few that support OIDC, but not all of the security features yet. So this would be like GitLab or CircleCI. And I'll talk a little bit later about what sort of security risks and security considerations you would want to consider when adopting this approach. In terms of the cloud provider, this isn't a vendor talk, but of course, this could be like HashiCorp Vault. This could be any of your AWS, GCP, Azure, or we'll see in a little bit, there's some additional tricks that you could do to work with other people who aren't a cloud provider. So the flow is mercifully much simpler. So here, the user is initiating a build, but it could also be happening automatically. Since your CI/CD system is your identity provider, it can just provide the signed JWT directly to the cloud infrastructure provider. Ahead of time, you would have created some sort of service account or role or something in the infrastructure provider saying that you have this trust relationship. And then crucially, you would add additional conditions to that trust relationship. We'll talk more about that in a second. Then the cloud infrastructure provider just reaches back to the CI/CD system to validate the signature. And then usually instead of making one API call, you'd receive some sort of like session token, good for half an hour that you could use to make whatever API calls you need to fetch secrets, store the build when it's done, that sort of thing. So let's talk about what the JWT looks like in detail, because this plays directly into our threat model and some of the wacky use cases we can use with it later. It has a header, which has the signing algorithm, as well as the specific key that was used to sign it. Really, though, the meat of it is in the body. Oh, I should mention, I posted in the Slack thread for this talk these slides, which include these links. So it's especially hard to click on an abbreviated link, but the full information is available on the slides. I didn't want to list out all the properties. There are a lot, but I wanted to call out some specific ones. There's the audience, which you can customize, very important. There's the SHA hash of the commit that started the build, also quite useful. There's the name of the repository, including, in the case of GitHub, both the organization and the specific repository, along with the repository ID, and then what workflow, the name of the workflow or the name of the build instruction file, basically, that runs the build. So why go into all that detail? Well, if you're using a shared CI/CD build system like Google Cloud Build or GitHub Actions, when you're configuring that trust relationship, you can't just say trust all of Google Cloud Build, right? There's thousands, hundreds of thousands of customers. You don't want other people accessing your cloud infrastructure. Instead, you need to, in that trust relationship, define specific conditions based on how paranoid you are. So to go back to that JWT, you could say, okay, any build for my organization, or maybe you want to only allow a handful of repositories. Or if you're very paranoid, you might want to say someone can't land an additional build script. It has to be this build script that has access to my infrastructure. So it's good to think about your risk tolerance, what sort of things you're willing to tolerate, what sort of things are fine. Another thing that we do in the JWT is we provide you not just the human readable name, but the underlying ID from the database of that object. So again, going back to the JWT, we have both the repository and the repository ID. In the case of GitHub, we have so many customers, brands are changing names, open source projects are incorporating to become companies. People will rename or they'll delete projects, leaving that namespace open again. So if someone deleted the Octo repo and then someone else went and recreated it, you would have a new ID in the database. So again, depending on if you're relying on something that you control directly or might be controlled by a third party, you might want that additional verification to ensure that the resource doesn't have a new owner. You can also customize the audience per application. So let's say that your build starts out by contacting HashiCorp Vault to get secrets, and then later deploys to AWS. When you get this JWT, you can request a custom audience, and you want to do that per application. So in a fortunate event that one of those providers is compromised, or that someone was able to intercept your network traffic, they wouldn't be able to use the token intended for Vault, and then use that to access your AWS infrastructure. This is the key feature that I would like to see implemented in providers like CircleCI and GitLab to kind of have this additional layer of security between your build system and your deploys. And last but definitely not least, in most situations, you're not implementing your own custom validation of the JWT, which is fantastic because there are a lot of well-known security pitfalls in JWT implementations. The specification allows you to have a signing algorithm of none, where there's no signature, and it validates with no sort of additional checks, which is scary. You want to make sure that the key is something the provider knows about. And so you just want to be careful if you implement your own JWT validation. And so why would you want to do such a thing? Well, here's where things get a little off the rails. I'm just going to check time real quick. So of course, you can use this with an existing cloud provider. You could also use this to access resources in your private network. The downside is, of course, then you have to host your own endpoint that it's reaching out to. So we open sourced a reference implementation of this. It's in the GitHub project namespace, but it works with any CI/CD provider that supports OIDC. And the idea is that you would run it in your private network, probably fronted by a load balancer. And then when your build system is running, it can use that token to authenticate itself to the gateway. And in the reference implementation, there's an example of both an API gateway and a HTTP Connect proxy. So if you need to publish a message to some internal service or do some other sort of custom non-cloud update as part of your build process, you can still build in the cloud and contact your private infrastructure using this technique without having to provision API credentials and store them statically. This technique scales horizontally quite well. Every validation check is sort of stateless. So you can have as many of these behind a load balancer as you'd like. The downside, of course, is that you have to run infrastructure on your private network, and you have to have internet ingress to your private network. So depending on your security requirements, this may or may not work for you. Continuing in the theme of going off the rails, so once we've gotten rid of API keys, why not get rid of all secrets? There's an open source project called sigstore, which is working on technology to allow you to sign your build artifacts without a durable signing key. It sounds insane. Truth be told, there still is a signing key. It just happens that it's ephemeral. And so in this situation, in your build system, once the build is done, you generate a ephemeral signing key pair. You take the JWT you get from your build system, the ephemeral public key, and a challenge, and you send that to Fulcio. Fulcio acts as sort of like a certificate authority. So it'll return to you a certificate that has baked into it the public key, along with all the build properties from the OIDC token. This starts to get very powerful when you talk about being able to audit builds and see what environment they were in, what build instructions they followed, that sort of thing. And then once you receive that certificate, you have the option of uploading both the signature and the certificate to a system called Record, which acts as sort of a public transparency log. So a lot of open source projects are opting into this model so that all open source users can easily verify the signatures of the open source builds. The developers of the open source project don't have to maintain a durable signing key, which is a major pain. And there's also a public transparency log of all the releases that are signed. So if there's an unexpected build, people can say, okay, well, wait, where did this come from? Who was the OIDC provider? What was the environment? Let's dig into this. And then I provided a link that has more information. sigstore, especially Fulcio and Record, is considered pre-production, but the open source team is working quickly on standing up production infrastructure that they would consider ready for general use. And so in a nutshell, that's build systems with OIDC. Again, the goal here is to make it so that we can build things in the cloud without having like API keys and shared secrets scattered around, and still enabling you to contact cloud providers, contact things on your own private infrastructure, and in this case, not have to maintain durable signing keys. Thanks so much.
Was there any questions for Zach? We did have one on the Slack. Let me double check back. Apologies. We got a question from another Zach. Is there a Python library that you're aware of for JWT verification so that you don't have to roll your own?
Ooh. There were a number of different approaches that I considered when implementing this reference implementation. I was like, surely this is a great time to learn Lua, and I'll write an Nginx plugin. I struggled with that approach. Then looking at the different options that were available, the least likely mistakes, the most mistakes were prevented by using the Go JWT library. So I chose to implement this reference architecture in Go. There's no reason why you couldn't use a Python library. Offhand, I don't know which one I would recommend. I'm about a year into my journey of understanding cryptography, so I'm a bit new to this specific field.
Yeah, first off, I wanted to say this stuff is extremely cool, and I'm so glad it got launched. One of the consequences of using this is you're pushing where the OIDC happens. The question of, is this build allowed to use the secret as close to the cloud provider as possible? And instead of having your own system or your own secret distribution to builds. A consequence of that is cloud providers have limits, and sometimes those limits are really, really tight. For IAM roles, for example, you get 4,000 characters. A problem we ran into is we just simply could not express all the builds that needed access to a secret for shared libraries that hundreds of things were using. Is that a pattern you have a solution for? Do you have recommendations?
Yeah. Let me think about that for a second. So what you're saying is that as your use case grows and you have more and more builds, you struggle with how to say which roles should be allowed by which builds.
Yeah, rather, if you imagine a library that hundreds of repositories need to use, and the role corresponding to that library would need to trust all those identities, and you just simply cannot express that sometimes with the primitives that cloud providers give you.
Well, this is a bit of a cop-out answer, but we should encourage our cloud providers to have more expressive role capabilities. I'm not aware of anything that we could do from the outside, I guess, to simplify that.
Was there any other questions for Zach? All right, well, thank you very much, Zach.